Hey, how's it going? This is Josh Pitts, author of BDF or Backdoor Factory. Um, it's late. I'm tired. However, I have an awesome update that I'm going to be pushing out soon, if it's not already out, and it's around the solving of the code cave issue. This has been around for 2 years, and I'll demonstrate the problem by patching putty. All right, so we're going to do the text section, data at number 13, and then also data at number 8. We have netcat listening over here. All right, so it failed because one of those caves did not like anything but nulls inside that cave. All right, then for zoom it on the 64-bit side, go ahead and show that. All right, let's do data. See that it executed normally, but on exit we get a crash, and we do not want to crash for the entire life cycle of the binary. It might show the user that something is amiss, and when you're doing a red team, you do not want to let the users know that anything unusual is happening. All right, so how do I solve this problem? Well, I created a stub that is only used when the payload is launched in a new thread. The stub goes on the beginning of the payload, and it will go through and clear out each payload in each code cave that was patched in memory, so self-modifying code, which is not new, and it will clean out each code cave, or zero out each code cave, or the payload, before, or right around the same time, it resumes execution. Okay? Um, it works great, and we'll demonstrate that with putting. Now, the payload needs to have threaded in it. Okay, I use virtual alloc and create thread, okay, to launch that into a new thread. Virtual alloc creates the memory section, then I copy over the payload and then create thread. And at the beginning of that payload is that stub that clears out the code caves. Okay, so text section, data, then number 8. You can see that it works. So, as usual, the payloads are going to be mirrored on the 64-bit side. All right. Let's do data, relock, and then another data section. And exit out. So let's get a view of the payloads. All right, so we have these are going to be reflected on the x64 and x86 side. They're going to be the same, just different sizes that fit that architecture. So we have IAT means it's the import address table, and then threaded is the payload that's supported. Now, because we have this, we can do full-on automatic patching. So just use the M flag, auto, not auto runs, automatic. And there you have. Use the Q flag to silence the ASCII banner, and it's much faster. And there it is. If you have any questions, just hop into IRC Freenode, pound BD factory, or submit an issue on GitHub. All right. Thanks for your time.